Hello everyone and welcome to Getting Started with Simple Windows. If you are new to Crestron programming or Simple Windows, then this video is meant for you. Feel free to follow along with the steps that I take. If you do plan to write the program, you will need a Crestron processor, which you can get from Craigslist or eBay. There's no guarantee on the quality of the product that you'll get, but they are pretty cheap. If you already have a processor, make sure that you download the touch panel file at the link shown at the bottom of the screen. Alright, so let's get started. For the configuration part of this, what you're going to do is open up Options and then Preferences, and then you're going to head on over to the Program Editing tab. You're going to change the symbol set from Common to Special. This will give you access to more symbols than you typically have available to you. And then in the Directories tab, this is where you change your default storage locations. I'm going to leave mine as they are, but if you want your default environment to be Google Drive or Dropbox or something, this is the place where you would change it. These are also the directories that Simple Windows will use to look for modules that your program may be using. And then the autosave tab, you want to make sure that the autosave is set up to something that makes sense for you. The disclaimer at the bottom pretty much tells you that autosave only works once you've saved a first time, because how can you save an untitled thing, basically. Alright, and then the last item is over under compiler settings. What you want to do is make sure that report warnings for Crestron modules and user project modules are both checked. I like to turn off the display crosspoint routing file, because if you do crosspoint programming, it'll bombard you with a bunch of stuff. And the last thing you want to make sure of is that the Create Archive button is pushed. So every time you compile your program, you will actually create an archive that will allow you to open up your program on another person's computer and include all the necessary stuff with it. Okay, so that's it. Your Simple Windows is now configured. Now we can actually do the programming part. It's pretty painless. Okay, so we're going to open up a new program, so go ahead and hit the New Simple Program button up at the top. This is going to be your header information, so we're just going to type in some stuff about it. This is we're going to say Getting Started. If you have a 3 series processor, you're going to want to add something in the program ID tag, because 3 series processors can have up to 10 programs running simultaneously. So I'm going to give mine just something generic, and we're going to hit OK. Alright, so once we've supplied that information, the next thing that we need to do is add a processor to our program. The program needs to know what kind of processor is going to be running this program. So if you expand the Control Systems folder, you'll see all of the available processors that Crestron has to offer. Scroll down until you find yours. Mine is an RMC3. So if yours is not an RMC3, what you see here will probably look a little different. That's not a big deal. Alright, so we've added our processor. The next thing we need to do is add the panel that we're going to use to it. So go ahead and expand the processor down here, and then expand the Ethernet slot. The next thing you're going to do is highlight IP ID 03, right-click that, and hit Add Item to P3 Internet. Mine's already selected, but a window of available devices will show up. If you don't see X panel immediately, go ahead and hit X on your keyboard, and the one that you want to have selected is just a regular X panel. Select that, hit OK, and now we have an X panel inside of our program that we can use to send and receive input. Now you may be wondering what the rest of these IDs are for. Well, you probably saw on that list there's a bunch of different items that we can add to these. The IP ID basically tells the processor what kind of device is going to be connected to a specific network slot. You can think of them kind of like network ports. It's a way for the processor to have a baseline understanding of what the connected devices are going to be able to do. Okay, so now that we have added our virtual panel, we're going to go ahead and navigate over to the bug view, or technically it's called the program view, but if you look at the symbol you can kind of tell why they call it a bug view. So we're going to head and hit that, and we get 3 views. We get the symbol library, under which we have the symbols that will perform all sorts of weird and wild and wonderful operations on the signals we are going to use in our program. The next is the program view, which has the device slots for our processor inside, and if you expand the Ethernet slot, you'll see that our X panel is inside of here. It also has the logic folder that will contain all of the modules that we use to do our programming. And then finally we have the detail view, which if you drag a symbol over here, you see it gives you all the details associated with that symbol. Alright, so I'm going to go ahead and get that out of my logic folder. And if we double click the X panel, you'll see that in the detail view for the X panel, there's a bunch of signal inputs and signal outputs. Inputs are on the left, outputs are on the right. Digital symbols use blue lines, analog symbols use red lines, and serial symbols use black lines. And so what's special about these signals is that these are tied to buttons or other interactive elements on a touch panel. So for instance, a button could be assigned an ID of 1, and anytime that button is pressed, press 1 will go high. And then what's neat about the X panel is that we can use these feedback joins to change the visual state of the button on the touch panel. So that's kind of what joins are in a nutshell. It'll probably make more sense once we actually do some programming. So what we're going to do now is, in the logic symbols folder under all symbols, we're going to look for a couple of symbols. We're going to look for a toggle, and these are in alphabetical order, so I'm going to scroll down here till I get to the bottom. I'm going to click and drag a toggle over to the logic folder, and then the next thing I'm going to get is an analog increment, which is back at the top because it starts with an A. And then lastly, the last thing I need is a serial input-output. Okay, so now we have 3 symbols that we can use to do our programming with. Let's do the toggle first. So the toggle has blue lines, which means it's a digital symbol. And what we're going to do is we're going to select press 1 from the X panel. We're going to give it a name of button 1. And when you press the spacebar, it automatically inserts an underscore for you. So hit enter, and then click and drag this signal over to the clock input on the toggle. And then what you're going to do next is highlight the outline on the toggle and name it button 1 toggle FB for feedback, or whatever you want to name it actually. And then you're going to click and drag this output to feedback 1 on the X panel. Now the next part's a little weird. We're going to take button 1 from press 1 and we're going to click and drag that straight to feedback 2 on the X panel. And the reason why we're doing that will become apparent a little bit later. Okay, so that's our toggle. We're going to go ahead and close that, and the next thing we're going to do is work with our analog increment. Alright, so on press 3 on the X panel, go ahead and give this a name. We're going to call that button 3, and then press 4, we're going to call that button 4, and then we're going to click and drag button 3 over to the up input on the analog increment, and click and drag button 4 over to the down input on the analog increment. Right, so inside of this symbol there are a bunch of what are called parameters, and these define how the output of the increment will behave when these inputs are changed. So what we're going to do, just type these in, don't have to worry about what they mean just yet. Type in 1% in the first parameter. Hold time, we're going to type in 0.2 seconds. Repeat time, we're going to put 5t, which is ticks, and ticks are basically hundredths of seconds. The lower limit, we're going to type in 0%. Upper limit, 100%. And then mute level, 0%. Fabulous. Okay, now the last thing we need to do is give the output of the analog increment a name. So I'm just going to call that analog feedback. And you may be wondering where we're going to put this. Well, we can't put it on the digital part of the X panel, because if we try to, it gives us an error. So what we're going to do instead is we're going to switch over to the analog inputs of the X panel by clicking that red button, and then we're going to click and drag the analog feedback over to ANFB1. This is going along very well, excellent. So we close the analog increment, we open the serial I/O symbol, and what we need to do is expand these inputs. And we can tell that these inputs are expandable because it has a little white arrowhead right here. A white arrowhead means that you can add more than one of these inputs. So I'm going to hit Alt and plus on my keyboard twice to give myself 3 inputs in total, and I'm going to navigate back to the digital side of the X panel. Oops, didn't mean to do that. And then on the serial I/O, I'm going to name these, button 5, button 6, and button 7, just to show that it doesn't matter where you type in the signal. So I'm going to take these, and holding shift, I'm going to select all of them, and then click and drag these to press 5, 6, and 7 on the X panel. Alright, so now we've got buttons that will make outputs of the serial I/O do stuff, and I'm going to add some strings inside of these boxes here. Whatever text we have inside of these boxes will appear on this output line when any of these buttons are pressed. So I'm going to add the obvious. And the last thing we need to do is give the TX output a signal name and bring it back to the X panel. So I'm going to call this something super creative that no one will ever think of. Text output. Okay, and then we can't obviously bring this to the digital side. We can't add this to the analog side, so thankfully there are serial inputs on the X panel. So I'm going to click and drag our text output over to text 01 on the X panel. And there's a couple of cleanup things I need to do here. If you look at these buttons, you'll see that there's no feedback tied to them. So if we push these buttons on the X panel as they are now, the button state won't change. Stuff will happen, but the buttons won't physically change how they look. So we're going to select all of these and then click and drag them over to the same join numbers. Alright everybody, give yourselves a round of applause, pat yourselves on the back, because you have just created your first simple Windows program. All that we have left to do is compile by hitting the F12 button. Wabam. We're going to save it because we haven't done that yet, so let's do this right now. Getting started. Bam. And I'm going to replace what I have already, which is no problem. So we've got that compiled, and we're going to transfer it to our processor. If you have a processor in your house or wherever you're going to use this connection information to actually get to it, mine has this particular IP address, so I'm going to go ahead and send it. And off the program goes to the processor. Now, when you compile, there is the possibility that you could run into an error, and these are the gotchas that are associated with simple Windows. We'll go over a couple of these real quick. You might get something saying there are incompatible signals in this program. If you do, close the notification and look in the program view for anything that has asterisk, exclamation mark, asterisk in front of it. Expand the things that have these in front of them as much as you can, and check to make sure that any symbol or device has every applicable parameter and input or output filled out. If everything looks okay, but it's still giving you errors, you can right-click the symbol and select Make Symbol Complete. This won't necessarily fix any bugs, but it will at least get you to a point where your program can compile. The other thing you can try is to comment out the symbol that's giving you the problems. To do that, right-click it and select Comment Out Symbol. You'll notice 2 forward slashes appear in the front of its name, and again, this won't necessarily fix anything, but it will let your program compile. You may get warnings because commenting out a symbol makes everything on that symbol invisible to the compiler. And as for warnings, you may get something that says a signal has no driving source or has no destination. The best thing to do for these is to find the signal the program is referring to, and then just make sure that it's connected to the correct input or output of whatever symbol you're using. Okay, with those out of the way, we're going to go ahead and experience the fruits of our hard labors. So you remember that link to download the file in the beginning? Well, just in case you missed it, here it is again. You want to download that and extract it, and inside of that folder you're going to see something that says launch xpanel.exe. Your computer might give you a warning about it, but don't worry about it, it's totally fine. And once you open that, you should get something that looks similar to this. If it says control system disconnected, it just means that the X panel doesn't know which IP address you want to point it to. So what you're going to do is hit options, go to settings, and in the IP address, make sure that you have the IP address of your processor typed in, and then hit OK. Be amazed at how button feedback responds to your input, how analog values ramp at your slightest whim, and how the appearance of signal strings pronounces the glory of your programming mastery. But seriously, you should be proud of yourself. You've taken the first steps into the fascinating world of Crestron programming. Well, that just about sums it up for this video. If you have any comments, feel free to leave them below, ask us questions, make suggestions, or use any of the social media outlets to tell us how much you love us, because we love to hear how much you love us. We've also been working on a bunch of other videos that reference specific symbols inside of the simple Windows library, and if I must say, they are pretty cool. If you had a hoot, give those like and subscribe buttons a gentle tickle, and we will return for more simple programming goodness.